right, guys, we have a special guest with us today. Okay, it's Courtney, but she doesn't want to say hi. So we'll just move right along. So we are in our last last section of Unit 10, and we are still working on solving quadratic equations, and we're going to learn yet another way to do them. So what have we learned so far? We've learned graphing, we've learned factoring, we've learned quadratic equation, and now this last one is called completing the square. This might not look like much to you right now, but after you go through the whole video or maybe even through the whole packet, come back and look at this and see if you can make sense of what it's doing. This is going to be your process, but this is obviously in picture form, and I'm going to show you in basically algebraic form. So first, let's do some review problems. First of all, let's work on simplifying. So remember, when we have a quantity squared, you cannot, no, you can't just distribute the square. What do you have to do? Well, what's it mean if something's squared? It means you are multiplying it by itself 2 times, right? So that means we have x plus 4 times x plus 4. So we've got to multiply this all out. So we get x squared plus 4x plus another 4x, and then plus 16. And of course, we have like terms. I need to move that down. And then we would have x squared plus 8x plus 16. Same idea over here. Can't distribute the square, so we have to write it out twice, multiply it together. We get x squared minus 5x minus 5x and plus 25. Again, we have some like terms in the middle there, so we're going to combine those, and we get minus 10x and plus 25. Okay, so next let's try some factoring, which is what we just finished with in Unit 9. So if we were asked to factor this, we would look for a GCF first. There is not one. So then we count the terms. There are 3 of those. So that should tell us we need to do AC method. AC here is 9. And we are trying to find 2 numbers that multiply to 9 that add to 6. Those are 3 and 3. Because this is a 1 here, we can take that shortcut. So this factors into x plus 3 and x plus 3. What's another way to write that? X plus 3 squared. See where I'm going with this? Notice your initial problem here and here, and look at what those simplified into. Now going backwards, we had this that we got from factoring that. Can you see some patterns here? Take a second and look at these numbers and see if you can find patterns. I see a pattern that this number right here, if I double it, gives me that number. And if I square it, gives me that number. Is the same true here? This number doubled right there, and that number squared right there. And if I'm looking at it this way, when I'm factoring, this number is just half of that number, or the square root of that number. So see if we can do this without actually going through the process of factoring. Can I write it as a quantity squared, as a perfect square? I can. X, and then what goes here? Minus 7, half of that number. Okay, so what we're going to end up doing is solving problems with this. And you can see that these are the same things, just now equal to a number. So we already knew that this part factors into x plus 3 squared. And the big advantage here, so this is where we're building up to, if we have this whole quantity squared, how can we solve this? What's a really easy way to solve this? How can you get rid of a square? You can take the square root. But whatever you do to one side, you do to the other side. So the square root and the square, those are going to cancel. And so you just have x plus 3, and the square root of 100 is 10. But you have to keep in mind that when you put a square root into the problem, a plus or minus sign goes in front there. So we actually have plus or minus 10. Then our last step to get x by itself, we need to subtract 3. So what we have is x equals -3 plus or minus 10, but we can do that. We can split it into two separate problems, kind of like we did with quadratic formula. -3 plus 10, -3 minus 10. So here we get 7, and here we get -13. And of course, we can plug these back in and check them, make sure that those are the solutions. So let me show you that one more time over here. We already previously factored this left side. We know it is equal to x minus 7 squared. The big advantage, if you can get a perfect square here, instead of going through quadratic formula or graphing or completing, or not completing the square, that's what we're doing here, or factoring the whole thing. Remember, when we factor, we need it equal to 0. But if we can make it written with a perfect square like this, we can actually solve it just by taking the square root. Okay, when we have the square root and the square, they cancel. We remember we need the plus or minus sign in front of that side. And in this case, square root of 5 is not a perfect square. So we calculate it and we approximate it to 2, round it to 2.24. And then I need to add 7. So x equals 7 plus or minus 2.24. Okay, so we're going to split that into 2. 7 plus 2.24 and 7 minus 2.24. This one gives us 9.24, and again, these are approximate. And the other one gives us approximately 4.76. Okay? Now, what we're going to have to do in this section is we're going to have to come up with the way to get this perfect square. It's not going to be as simple as just factoring. You're going to have one step before this. The first thing you need to be able to do is figure out what number we have here that's going to allow us to write a perfect square. So these ones were already given to us. We already had these numbers. We had a perfect square trinomial, which means that when you factor this trinomial, you get a perfect square, one quantity squared. We need to figure out what number does that for these, and this is called completing the square, because you want to complete the perfect square. Well, in order to do that, if you didn't catch it back here, the connection between these numbers is b divided by 2 squared. So to complete the square of the expression x squared plus bx, you take this b, you divide it by 2, and you square it. So over here, remember we're in the form x squared plus bx. Our a is always going to be 1 here, so that's why it's not written in there. So you take b, which is 4, you divide it by 2, and then you square it. Well, 4 divided by 2 is 2, and then we want to do 2 squared, so we get 4. So b divided by 2 squared for this problem is 4. So what is our answer here? It's going to be 4. Then what they want us to do is they want us to take this trinomial and write it as the perfect square. So what quantity squared? Well, this is just going to be an x, and then what goes in here, remember what we were looking back here, the pattern, half of this number, which is also the square root of that number. But go with half of this. Half of b is what goes here. Half of 4 is 2. Let me show you that again over here. So first of all, what is your b in this problem? B is -16. Then you want to take that b, you want to divide it by 2. So b divided by 2, that now gives you -8. Then you want to take that number and square it. So -8 squared is 64. So the number you need to add is 64. Then write it as the perfect square. So here this number completes the square, and then we write it as the perfect square. And that is always just going to be your x, and then half of this number, so -8. And you can always check these by multiplying it back out. Okay, so this all leads us to what we want to be able to do is solve a quadratic equation using this method of completing the square. So if you missed everything I've said so far, this is what you need to be able to do, starting here. Okay, so in order to solve by completing the square, you want to make sure you are in the form x squared plus bx. You want just that to be on your left side, and you want everything else that you're equal to be over here. So all the rest of the stuff over there, whatever it happens to be. So we have x squared plus bx. In this case, it's a negative 12 for your b, but we want to get rid of this 5. We don't want it on the left side. This is different from when we solve quadratic equations using quadratic formula. We always wanted to be equal to 0. So this is a little different, but it will make it easier to solve. So we do that, then we have, oops, I'm not reading, x squared minus 12x equal to negative 5. Okay. Then you're going to find the number, just like we were doing up here, find the number that we have to add to complete the square. The way you find that number is you find your b, you divide it by 2, and you square it. So in this case, what is our b? I already said it, it's negative 12, and then you're going to divide that by 2 and square it. Negative 12 divided by 2 is negative 6. Negative 6 squared is positive 36. By the way, this number should always be positive, because whether you square positive or negative, you get a positive. So we need to add 36, which is what this is equal to, but whatever you do on one side, you do to the other. So now we have x squared minus 12x plus 36 equals 31. At this point, we need to do the second half of completing the square, which is where we write it as a perfect square trinomial. Not a perfect square trinomial. That is your perfect square trinomial. Now we want to write it as the perfect square binomial. And that essentially what you are doing from this step to this step is you're factoring, which is what we were doing back here on examples 3, 4, 5, and 6. The shortcut, though, instead of going through that full long AC method process, is it's always going to be half of your b, which is negative 6. So it's just going to be that portion of it. Okay? So really understand this here. The number that you are adding in my red step, the number that we're introducing into the problem, that is b divided by 2 squared. Then when we go to write it as the perfect square here, the number that you have here, the shortcut, is just b divided by 2. So these are like your two things you really need to understand. If you don't see what is happening here, let me do a little side piece here. What I'm actually doing is I'm factoring this. And I would do that with AC method. So I'm looking for something that multiplies to 36 that adds to negative 12. Those two numbers are negative 6 and negative 6. So I could replace my middle term with those two numbers, split it in half, factor each side, and I'd be left with, I have factors of x minus 6 and x minus 6, and another way to write that is x minus 6 squared, which is exactly what I have here. So technically what you're doing is you're factoring this red left side. However, I don't want to do all this work every time, and I'm sure you guys don't either. So the shortcut is take half of b and put it right there. X minus b over 2 squared. Very similar to your b over 2 squared there. Okay? Then you're going to solve this. And this is what we were talking about at the end of these examples. It's really convenient if you have a quantity squared, because then all you have to do to get rid of that square is take the square root. Square root here, square root here. But you must remember, in front of your square root goes a plus or minus sign. Because remember, when we solve quadratics, we could get two solutions, and that's where you're going to come up with those, with that plus or minus sign. So your square root and your square cancel, and all we have on the left side is x minus 6 equals plus or minus the square root of 31. Type it in your calculator. And we're going to round to the nearest hundredth, so 5.57. Then to get your x by itself, you're going to add 6. So we have 6 plus or minus 5.57. And at this point, you're thinking, okay, I need to break it into two problems. 6 plus 5.57 and 6 minus 5.57. Calculate those. 11.57 and 0.43. These are approximate, so I should technically have the squiggly equal signs. Approximate because I rounded. How can you check these? Well, you could plug them back in. Again, because they're approximate, you're not going to get exactly 0, but you should get very close to 0. You could also check these by doing them a different way. You could try quadratic formula. You could try graphing and see if you get the same solutions. All right, let's try another one. Okay, to solve by completing the square, remember we need to be in the form x squared plus bx equals everything else. So our first step here could be to subtract the 30. Then we have 2x squared plus 12x equals negative 30. Well, we still don't have this form because we have a number right here and we don't want that number. So to get rid of it, we need to divide. This is multiplication, but be careful, you've got to divide everything by that. This becomes a heart problem. These cancel. And then when we do it on this side, 12 over 2 is 6x. Negative 30 divided by 2 is negative 15. So you just need to make sure you divide everything by the 2. Everything. Every piece. Okay, so now we have this nice new problem to work with, set up in the correct format. What we want to do is then, kind of writing out some steps here, you might want to write these down. Step 1. Step 2, we want to find b divided by 2 squared and add it on both sides. So you might want to elaborate on these basic steps I'm writing. Put it in this form. Add this to both sides. Well, in this case, b is 6. We need to find 6 divided by 2 squared. 6 divided by 2 is 3. 3 squared is 9. So we are adding 9 on both sides. Okay. This side, of course, is negative 6. And then what you want to do on your left side is you want to factor the left side. But keep in mind, there's a shortcut to just get you straight to your quantity squared. And that is always just going to be b divided by 2 right there. So this is x, something squared. Your something squared is your b divided by 2, and that is 3. So these two numbers, these special little numbers that we are having to put into our problem are a little different. They're similar but different. This one is b divided by 2 squared. This one is just b divided by 2. Sometimes I'll get students, once they understand this process, they'll say, well, why don't we just go straight from here to here? If I can get my b here, which is 6, and divide it by 2 and put it there, why do I have to do this green step? And the reason is, if you went straight from your red step to your blue step, this wouldn't be negative 6, it'd be negative 15. You would forget to add that number on the other side. So you do need to have both of those steps. At that point, you can continue solving. The advantage is it's easy to solve now. We just take a square root of both sides, just keeping in mind we need the plus or minus. A square root and a square are inverse operations, so they cancel, and we're left with x plus 3. But we have a problem over here. We can't take the square root of a negative number. So just like with quadratic formula, that tells us there is no solution. Okay, so if you get square root of a negative, you still will not have a solution, which means when you graph it, you're going to get some parabola that's either way up here and never crosses the x-axis, or something way down there that never crosses the x-axis. All right, let's try another one together. What? No. For lunch, yes. Totally recording that. Sorry, guys. Oops. Okay, so this one is in the correct format. Remember that. Whoa, I don't want to highlight. The correct format is x squared plus bx equals everything else. Scribble, 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 whatever else is there. We're already good there. That was step 1. I guess I should finish these steps back here. The last step then is to solve, and that's usually going to be taking a radical of both sides. Don't forget plus or minus. Elaborate on those steps as you want. Okay, so after we do step 1, getting it in the correct form, step 2 is to find b divided by 2 squared and add it on both sides. Well, in this case, negative 5 divided by 2 squared. Negative 5 divided by 2 is negative 2.5. You can leave it like that, or you can leave it as a fraction. Personally, I like to leave fractions because fractions are superior to decimals, but you do you, whatever you want to do. When I square it, I would get 25 over 4, or its equivalent decimal, which is 6.25. Sometimes when you get fractions, though, you end up starting to round too soon, or when you use decimals. So I would caution using decimals. I would try to stick with fractions when possible. So adding on both sides, 25 over 4. After we find that, then technically what we are doing is we are factoring the left side. But remember, there's a shortcut. It's going to be x plus b over 2. Well, in this case, b over 2 would be negative 5 over 2 squared equals 7 plus your 25 over 4 gives you 53 over 4. Pop that right in your calculator. Okay, at that point, you are ready to solve. And remember, you are solving by the square root. Take square root of both sides. Square root and your square root cancel. We get x minus 5 halves equals, don't forget your plus or minus. Plus or minus the square root of 53 over 4 is approximately 3.64, rounding to the nearest hundredth. Then you're going to add 5 halves to get x by itself. So we have 5 halves plus or minus 3.64. And then it's just a matter of calculating this twice, once with the plus sign and once with the minus sign. I don't care if you guys don't show me this broken up into 2 problems. It's up to you if you need that or not. Just don't forget that there are 2 separate problems. All right, I'm punching that in my calculator. I get 6.14. And punching the second one in, I get negative 1.14. Technically, they should be squiggly equal signs because we have rounded, so we're no longer exact. 2 solutions. Okay? Pause the video. You guys try this one on your own. Really pause it. Really try it. See if you can get it. Okay, compare what you've got with mine. Check your work. See if you came out with my same answers. Keep in mind you can check these multiple ways. You can check it by plugging it back in, each one separately. So you'd plug 2 squared plus 6 times 2 minus 16, see if you get 0. Do the same thing with negative 8. Keeping in mind you need to square the negative included, so parentheses. You also could graph this, see if that's your zeros. You could use factoring, see if you end up with that when you solve, or you could try quadratic formula. So all of these are ways that you can check your answers. Also keep in mind you could get no solution if you have the square root of a negative number, or if you get the square root of 0, then you would only get 1 solution, and that is okay as well. Okay, this is a hard section, I think, so if you need some extra direction, extra instruction, please come back and see me, and we can go through another problem or 2 together if you need that. Okay, all right, good luck wrapping up this unit.